You ever hear one of those stories that sounds just way too wild to be true? But then you find out it's actually a breadcrumb trail, and it leads to something so much bigger. Well, that is exactly what we are going to unravel today.
So, a few years back, this headline was literally everywhere. It was all over the internet. The claim that scientists down in Antarctica had found cold, hard proof of a mirror universe, an antiverse where time itself actually flows backward. I mean, it sounds like something straight out of a movie, right?
But you know how it is with these sensational stories. The truth is usually a little more complicated. And honestly, it's a lot more interesting. So let's get into what was actually happening deep beneath the South Pole.
Okay, so this whole story doesn't start with parallel worlds. It starts with a very real, very cool experiment and a very weird little particle.
It all comes down to this, the neutrino. People call them ghost particles for a reason. Right now, trillions of them are passing right through your body, every single second. They barely interact with anything, which makes trying to find one incredibly difficult. So, how in the world do you catch a ghost? Well, scientists built this ridiculously clever trap. It's a giant balloon called Anita, and it floats way up high over the Antarctic ice sheet. Now, it's not looking for the neutrinos themselves. It's listening for the tiny, faint radial pulse they make when they finally slam into the ice below. Think of it like trying to hear a single pin drop in the quietest, most frozen desert on Earth. And then, it happened. They detected something that should be flat out impossible. They got a signal showing a high-energy neutrino, but it wasn't coming down from space. It was shooting up, out of the solid Earth. Now, according to the standard model of physics, our rule book for the universe, that just shouldn't happen. A particle that powerful should have been stopped dead by the planet itself. So of course, the first thing they did was check everything. Was it just a glitch, an error in the equipment? Nope, the signal was real. Okay, so then they called up another observatory, IceCube, to see if maybe there was some kind of source on the other side of the planet blasting it through. The answer? A big ol' nothing. So, once they ruled out all the normal explanations, some physicists started thinking way outside the box. And that's where the crazy headlines came from. That wild idea that maybe, just maybe, this particle shot out of a mirror universe, where the laws of physics are flipped upside down.
So, let's be clear. The big takeaway here isn't, hey, we found a parallel universe. It's that we found something so fundamentally strange, it pushed the absolute boundaries of known physics. And that weird signal? It's not just a one-off thing. It's like finding one loose thread on a sweater, and you suddenly realize the entire foundation might be starting to show some serious stress. This is where the story gets way bigger, and it leads to what some are calling a full-blown crisis in cosmology.
All across the board, when we study the universe, our best theories and our most precise measurements, they're starting to disagree. And they're disagreeing in really fundamental ways. They need a signal as just one symptom of a much bigger condition.
Okay, take something called the Hubble tension. We have two super precise ways to measure how fast the universe is expanding. The first method looks at galaxies close to us. The other one looks at the ancient light left over from the Big Bang itself. Here's the problem. They give us two different answers. It might not look like a huge difference on screen, but for cosmologists, this is a massive five-alarm fire of a disagreement.
And then there's dark matter, the invisible stuff that acts like the cosmic glue holding entire galaxies together. Our models predict it should clump up in these really dense, spiky cores at the center of galaxies. But when we actually look out there with our telescopes, what we see are smooth, soft cores. It's like our theory predicts a jagged mountain peak, but reality is showing us a gentle, rolling hill. They just don't match.
And believe me, the list goes on. The James Webb Telescope is spotting these impossible galaxies in the early universe that look way too old for their age. We have the lithium problem, where the oldest stars just don't have the amount of lithium our Big Bang theory says they should. Oh, and don't even get me started on dark energy. It makes up 70% of everything, and we still have basically no idea what it is.
All this cosmic uncertainty, it can feel really abstract, right? Super distant. But what if that same feeling, that sense of vast, undiscovered territory, isn't just out there in deep space, but is actually right here on our own planet?
Yeah, we tend to think of Earth as this fully mapped, totally explored place, but you'd be surprised. Some of its biggest features are still completely hidden from us.
Let's just go back to Antarctica for a second. We've been studying that place for over a century. You'd think we know it pretty well by now.
And yet, buried under miles of solid ice are the Gamburtsev Mountains. We're talking a mountain range as big as the European Alps that no human has ever seen with their own eyes.
The sheer scale of what's still hidden is just mind-boggling. A colossal feature of our planet, completely invisible.
And it's not just mountains. Get this. During the last ice age, sea levels were so much lower that a huge landmass called Sunland connected most of Southeast Asia. You could have walked from modern-day Vietnam to Borneo. Early humans lived and walked across an entire continent that is now completely underwater. A lost world, right on our own doorstep.
So, what does all this mean? We've got a rogue particle from the ice, a universe that can't agree with itself, and hidden continents. What's the connection here? Here's the single most important thing to get. None of these things are failures. That bizarre neutrino, the Hubble tension, the mountains under the ice, they aren't mistakes. They are signposts. They're pointing directly to the edge of our map of knowledge, basically screaming, hey, the really interesting stuff is over here.
This quote just nails it perfectly. A crisis in science doesn't mean everything we know is wrong. It's the exact opposite. It means we're on the verge of learning something new, something huge. It's the sound of a door cracking open to a much, much bigger room.
That strange signal from Antarctica didn't prove there's a parallel universe. It proved there are still gigantic mysteries right here in our own. These gaps in our knowledge, they're not problems we should be afraid of. They are invitations. Invitations to get curious, to push harder, to explore. And really, that just leaves us with the most exciting question there is. What are we going to discover next?